Welcome everybody. I hope you had the opportunity to stop and pause, rewind with those first two videos because that is showing that you're able to self-monitor your pace. So do whatever you needed with those first two videos, but now this video is going to provide you with the answers to all those questions. So I hope that you did attempt them and so that we can share these together and you can compare. And any questions you may have about these, please write them down so we can ask them on Wednesday together. And I'd love to discuss these in more detail with you. But I appreciate you guys working on your own today. So the first part says invent a situation, and I chose dealing with cars, in particular race cars. The next part says to label the axes with quantities in your situation. So in this case here, my x-axis dealt with minutes, and my y-axis dealt with miles, because how many minutes I go depends on how many miles I'm going to travel. The third question said to give the graph a title, and I could give this any name. I chose speed of a car. I could say miles traveled per minute. I could say race car timing, whatever that may be that deals with my situation. And then question 4 says, there is a point on this graph. What are the coordinates? So when I look at this point, I see that this was 16 and this was 12. And I write my coordinates as my x first, then my y. So my x came first, so that's why I wrote 16. My y came second, which was 12. So 16 minutes in 12 miles. So 16 minutes in 12 miles. As we get into Tyler's walk, the first part here was to look at this graph and realize what this point means for us. So at the last video, the first one, we looked at this and it said elapsed time and then distance per meter here. So I know that we write it as x and y. So 40 is going to represent 40 seconds in 50 meters. So what does this mean in regards to Tyler's situation with the ticket booth? Well, at 40 seconds, he traveled 50 meters from the ticket booth. So once again, in 40 seconds, he traveled 50 meters from the ticket booth. That's what 40 and 50 will represent. Now for this next part, it says the table representing Tyler's walk shows the value of the time and distance. Complete the table and then plot the grid. So when I was looking at this table, it's all done except here, right? So what I decided to do is if we think about last week, we found our coordinates on our table, we would take our y and divide it by x, and that would give us our ratio. And when you do that, y divided by x, you're going to find out that you'd get 1.25 for 1. So if how I found out 1.25, well, I saw 40 here, and I said 40 divided by what gives me 1, and that was 40. So what you do to one side, I have to do to the other. So it's 50 divided by 40, and I got 1.25. So for 1 second, I traveled 1.25 meters. Knowing that, I'm able to graph the rest of this. So this 0, 0 is the origin. This 20, 25, so into 20, then 25. Next one was 30, and I know this was 35 right here, and this is 40. So I put it right in the middle at 37.5, and then 40 to 50. And my last one, 1. So this was a rough estimate, obviously. I could only get this as close as I could, but I said 1 was about here. And this was 5, so I put about 2.5 or 1.25 here. I would say I'm a little off on this, but we get the gist that it's going to be closer to 0, 0. As we look at this table, we're going to determine some things. So what does 0, 0 mean? Once again, 0, 0 represents the origin. Before any time has started, there is no distance traveled between Tyler and the booth. For question 2, how far from the ticket booth was Tyler after 1 second? Well, we know after 1 second, he was 1.25 meters away. Okay, so now we're aligning our table to make sense of these questions here. And what is the constant of proportionality here? Well, we know that for every 1 second, he travels 1.25 meters. So we could say the constant of proportionality is 1.25. It tells us that Tyler walks at a speed of 1.25 meters per second.